Hi, this is Benjamin Bates, and this is my project video for Math 251, Differential Calculus. Yeah. I hope I can explain this okay, but we'll see. Alright, so this is the first page of the project, and it's the first question. I have all my answers on the same sheet of paper. I'm sorry that is a problem, but I'll make do. So context. So the first question and the context behind it. Let's read it. So suppose you leave school, which is 5 miles from home. You are confused since you just finished taking your calculus test and you bike in the opposite direction from home for a while. Later you turn around and head toward home again. But since you are so dehydrated and confused, you end up turned around again a short time later. Let the function s of t be your distance in miles away from home at time t in hours. Include units in all answers. So the function s of t is equal to t cubed minus 8t squared plus 16t plus 5. And we're looking at the graph over the time interval from 0 is less than or equal to t, and t is less than or equal to 5. So this is the graph, and as you can see here, this is time t is 0, you're 5 miles away from home, which is what it says up here. Suppose you leave school, which is 5 miles away from home. That's your t0, 5 miles. Anyways, find and interpret s0 and s5. Show these values on the graph. So let's come over here. So I got s of t is equal to distance in miles, and t is equal to time in hours, and we're looking at the graph over the time interval from 0 is less than or equal to t, and t is less than or equal to 5. Once again, s of t is equal to this. At time t equals 0 hours, you're 5 miles from home, you're at school. And that's my bad drawing of the graph. Anyways, A, find and interpret s of 0 and s of 5, show the values on the graph. Oh god, this is horrible. Alright, s of 0, 0 cubed minus 8 times 0 squared plus 16 times 0 plus 5, all results out to 5 miles. You're 5 miles away from home at t equals 0, because you're still at school. S of 5 is 5 cubed minus 8 times 5 squared plus 16 times 5 plus 5, which all sums out to s of 5 is equal to 10 miles. So at s of 5, you're 10 miles away from home. Let's move this a little bit. So at t equals 5 hours, you are 10 miles away from home, which is this point here on the graph, assuming home is the t-axis. So now the next question is, what were the maximum and minimum distances you were from home, and when did they occur? Show these values on the graph. The maximum distance, what were the maximum and minimum distance you were away from home? Alright. So, in order to find the maximum distance away from home and what time it occurred, we must find the coordinate point t s of t of the vertex at the highest point on the graph. In order to find the minimum distance away from home and what time it occurred, we must find the coordinate point of the vertex at the lowest point on the graph. So we need to find the highest point, the vertex here, which is the highest, which is the farthest distance away from home, and here's the lowest vertex, which is the minimum distance from home, the closest distance you are from home. So let's look at the next page. A beautifully easy way to find the coordinate point of the two vertexes is to use calculus. Notice that the slope of a line tangent to either vertex on the graph would be a slope of 0 or a horizontal line. Oh, something like that. Using calculus methods, we can derive an equation m of t from the original function s of t, such that each output of mt will be the slope of a line tangent to a specific value of t on the original graph s of t. Oh god, this is horrible. Okay, if s of t equals t cubed minus 8t squared plus 16t plus 5, and m of t is equal to s prime t, or the derivative of the position function or function s of t, then d over dt of st is equal to d over dt of t cubed minus 8t squared plus 16t plus 5, which is also equal to d over dt of t cubed minus d over dt 8t squared, and then we get m of t is equal to the derivative of s of t, which is equal to 3t squared minus 16t plus 16, and so we have our derivative of s of t, and our derivative is an equation that when we put in a value for t, put in a value of t, we get an output of a slope that corresponds to a tangent line on the original graph of s of t. So now that we have our derivative of st, tangent slope equation of st, we can observe back to the previous endeavor of finding the coordinate points of the two vertexes on the graph, maximum and minimum distances from home of s of t. Okay. Since mt is equal to s prime t, which is equal to 3t squared minus 16t plus 16, is the equation where the output values of mt are values of slopes of tangent lines on graph s of t. For input values of t, we can set m of t equal to 0, which means we are looking to find the input values of mt that result in mt being 0. Based on the graph of st, it is observable there are two t values where the lines tangent to the graph of st have a slope of 0, horizontal lines. There are two vertexes. As you can see, there's a highest point, a lowest point, there's two vertexes, and at that point there will be horizontal line with a slope of 0. There's two, and our derivative function is a quadratic, which when we solve for t will give us two answers. So yeah, interesting. So we set mt equal to s prime t equal to 0 and solve for t. Quadratic formula to find the values of t that result in mt being 0. Substitute t for x because we're using t. T is equal to time in hours. 0 equals mt, 0 equals this, 0 equals 3t squared minus 16t plus 16. Use the quadratic formula, do all that. We get pretty nice values for t that are not roots or imaginary, so that's cool. So we get t equals 4 and t equals 4/3. So when the time is equal to 4 hours, and the time is equal to 4/3 hours, 1 1/3 hours, 1 1/3 hours. The slope will be 0, which is what we're looking for. Which is when we plug this back into the S of t, we will get a result of 0, which is what we want. So, let's see. Our two t values that result in m of t being 0 are t equals 4 hours. Why did I not write the units? 4 hours, and t equals 4/3 hours. At these two t values, there are tangent lines with slope 0 on the graph of s of t, position function. To find the distance in miles value, output value of st, we plug in these two t values and solve. So in order to find the coordinate point, we plug in s of 4 hours comes out to be 5 miles. Now we solve for t equals 4/3 hours. Do all this nice fractions, and we get to s of 4/3 is equal to 391 over 27 miles, which is approximately 14.481481 repeating miles, which is about 14.5 miles. So, the coordinate point of the vertexes are, I think I wrote it down, that'll be easier. We now have our coordinate points of the two vertexes on the graph ST. These points are 4 hours, 5 miles. At the point 4 hours, we're 5 miles away from home, and that is a turning point where we start to head back away from home once again. But right there, at the vertex, there's a slope of 0. Anyways, so the first point, so the point of the lowest vertex, or the minimum distance away from home, is 4, 5, where t is 4 hours and s of t is 5 miles away from home. And the highest point on the graph, the highest vertex, when we are farthest away from home, will be at t equals 4/3 hours and 391 over 27 miles, which is about 1.3 hours and 14.5 miles. So the maximum distance from home in miles is about 14.5 miles. The maximum distance from home occurred at about 1.3 hours after leaving school. The minimum distance from home is 5 miles, and the minimum distance occurred at 0 hours before leaving school and at 4 hours after leaving school. So now we do the next question, which is 1C. Over what time intervals were you moving toward home, away from home? Show these intervals on the graph. So, at the time intervals of 0 to 4/3 hours, you're traveling away from home. As you can see on the graph, we started out at t equals 0, 5 miles away from home, we're at school. We start to travel away from home as time passes, we're moving further away from home. And at the time intervals of 4/3 hours to 4 hours, we're traveling toward home. So we're traveling away from home up to this point at the vertex of t is 4/3 hours. We start to turn back around and head back toward home, all the way down to t equals 4 hours. And then somehow, because we're so dehydrated and confused, we turn around again and start heading back away from home at this point, which is right here. You were traveling toward home. Is that time interval? No, wait. Yes. Traveling toward home. That time interval. And at the time intervals of 4 hours to 5 hours, you were traveling away from home again. Now, here, it's just question 1. Question 2. Use derivative rules to find the velocity function v of t equals s dash t s prime t derivative of st, something like that. So do that. So as you can see, we have previously found this function earlier and interpreted it with finding slopes of tangent lines. The derivative of a function can be interpreted both as a function to find slopes of tangent lines as well as the velocity of an object. We will now re-examine our derivative mt equals s prime t, which is equal to vt, as velocity instead of tangent lines, even though they're the same. So the derivative is this, 3t squared minus 16t plus 16. It then asks us to, for 2a, use a calculator or desmos.com to create the graph of the velocity function. Match the given window used for the position function. Horizontal axis 0 to 5, vertical axis 0 to 20. Label the units for both axes. So I'm going to show the graph on Desmos, but I also drew it pretty poorly because that's what I do. And so we have the graph. Time, t hours, horizontal axis 1 to 5. Vertical axis, vertical axes, I can't speak, it's in miles per hour, up to 20, down to -7, because our lowest point is -5 on the derivative graph, or the velocity graph. The derivative st, which is 3t squared minus 16t plus 16. Those are our points. If we look at Desmos, you can see our graph. Interesting. Anyways, so graph, we did that. It's good. Alright, so question 2b. Find and interpret v of 1 and v of 3. Show these points on the graph and explain what the function values mean. Here's the graph of the velocity function graph of vt. So 2b. Find and interpret v of 1 and v of 3. Show these points on the graph and explain what the function values mean. So v of t is equal to this, 3t squared minus 16t plus 16. V of 1 turns out to be 3 miles per hour. The velocity at t equals 1 is 3 miles per hour, which is also the slope of the line tangent to the point in time t equals 1 hour. V of 3 turns out to be -5 miles per hour. The slope of the line tangent to the graph s of t at time t equals 3 hours is -5. This is also the velocity of the traveler on the graph s of t at time t equals 3 hours, where the velocity traveled is -5 miles per hour. So if we look, show these points on the graph. So we look at the graph, at the graph of st, the point t is 1 hour. The tangent line to that point, there's a slope of 3, which is also a velocity of 3 miles per hour. At the point t equals 3 hours, there is a negative slope here of 5, which corresponds to -5 miles per hour for the velocity. And we look at the parabola, so on the parabola, t of 1 is 3 miles per hour, t of 3 is negative 5 miles per hour, t of 0 is 16 miles per hour. So the slope or the velocity at t equals 0 on s of t is 16 miles per hour. Our velocity is decreasing. Our velocity is decreasing with respect to time. And then we approach our 0 point where velocity is 0, which corresponds to the horizontal tangent line of the highest point on the graph of s of t, the vertex. And then our slope continues to decrease, although the numbers are moving away from 0. The speed, the absolute value of the velocity, is increasing, but the velocity is still decreasing. So from t is 0, our velocity is decreasing, we arrive at 0. We're still technically decreasing, although it's moving away from 0, and it's increasing in a negative direction. Our speed is increasing, yes, but our velocity is still decreasing because it's negative up till v of 3. And at that point, v of 3, our velocity begins to increase or move back towards 0. It's negative here, but it's moving back towards 0. It's increasing, arrives at 0 at that horizontal line, tangent to the vertex, and begins to increase in a positive direction, which corresponds to this. So decreasing up till t is 3 hours, and then we're increasing from t equals 3 hours. Our velocity is increasing all the way up. So our velocity, although negative here, begins to increase towards 0 and then past 0 and increases at that point. So v of 1 is equal to 3 miles per hour on the graph v of t equals s dash t equals 3t squared minus 16t plus 16. The velocity of the student riding their bike is decreasing with time, and at t equals 1 hour, the velocity is 3 miles per hour. The student continues to slow their velocity down with respect to time and has a short break where the velocity is 0 miles per hour at t equals 4/3 hours, which is the vertex on s of t, the highest point away from home. It's the turnaround point. The velocity is 0. They then travel back. They then travel back the way they came from, with their velocity being negative, moving further away from 0 in a negative direction. Their speed, or absolute value of their velocity, is increasing up until t equals 3 hours. The overall velocity is decreasing from v of 1 up till v of 3, even though the velocity from v of 4/3 to v of 3 is increasing in a negative direction on the graph of s of t. So even though it's increasing away from 0, although it's negative, it's increasing away from 0, although it's negative. It's still decreasing because it's negative, and it's shown on the graph of the derivative, the graph of the velocity function. Although we arrive at the vertex and we move away from 0, we're still decreasing. The velocity is still decreasing, although the numbers are getting larger from 0, away from 0. We're still decreasing, and at the point v of 3, we begin to increase our velocity. At v of 3, our velocity, although it's still negative, it begins to increase towards 0 and then head past 0 in a positive direction. So from v of 3 to v of 5, the velocity is increasing. From v of 0, or not v of 0, v of 0, this is s of t, but we're looking at velocity. So from v of 0 till v of 3, although the velocity is positive over here, it's decreasing towards 0, decreasing, it continues to decrease, and then at the point v of 3, we begin to re-increase. So, at t equals 3 hours, the velocity is v of 3 equals -5 miles per hour. And for the time after 3 hours, the velocity begins, although negative, begins to decrease on the graph of st, or increase toward a velocity of 0 miles per hour at t equals 4 hours. The time after t equals 4 hours, the velocity is increasing in a positive direction. So I probably just confused myself, but decreasing, 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 up till v of 3, which is right there. Our velocity is -5 miles per hour at that point, but our velocity begins to increase from that point onward. It's shown on the parabola. Decreasing up till v of 3 begins to increase. Alright. So, that's 2b. Now we have question C. Alright. As you trace the velocity function with your finger or pointer, describe the velocity and its changes from 0. Wind is very helpful. Find and interpret. As you trace the velocity function with your finger or pointer, describe the velocity and its changes from 0 to 5 hours. Be sure to use the appropriate units. I didn't hear a single thing I read, but that's fine. Okay. So, wait, that's 2C. Wait, I just did that. Yeah, sorry, I just did that. Okay, so question 3. Use derivative rules to find the acceleration function, or the acceleration function is the derivative of the velocity function, which is the double derivative, second derivative of the position function s of t. And we do that here. So, use derivative rules to find the acceleration function. V of t is equal to 3t squared minus 16t plus 16. D over dt of vt is d over dt of 3t squared minus 16t plus 16, which we arrive at acceleration function a of t is equal to 6t minus 16, which is a linear equation. And at is in miles per hour squared, I'm pretty sure. So now we're going to do 3a. So we have our derivative, we have our acceleration function. It is shown there. It is 16 minus 16. We have our acceleration function. Now 3a, use a calculator or Desmos.com to create the graph of the three functions together. Use different colors for each function and label each function. Match the given windows used for the position function. Horizontal axis 0 to 5, vertical axis 0 to 5. Alright, so using Desmos for this and not a calculator, because calculators are difficult and I couldn't color them on my calculator. So this is the graph of the velocity function, the parabola. This is the graph of the position function, function s of t, and this is the acceleration function. It is a linear function. Now all of them together is this. So what do we do now? What's the next part of the problem? So graph. So we graphed them. The color for position function s of t is red in this case. The color for the velocity function v of t is blue. And the color for the acceleration function a of t is green. I had different colors earlier. They were swapped, but I used the same three colors when I wrote it down. But anyways, so 3b. What is 3b? Let's look. So 3b. Locate the zeros, horizontal intercepts of each function. Point to each one and describe what is significant about those points. What is happening there that causes the values to be changing from positive to negative or negative to positive. So we need to find the zeros of s of t first, so we'll do that. Now, I have the zeros written out. I'll try to explain them best of my ability in a second. But the zeros of st is about negative 0.274 hours with a 0 miles, which is insignificant in my opinion. The zeros of vt, the velocity function, are t equals 4/3 hours and t equals 4 hours. The zeros of the acceleration function are t equals 16/6 hours, which is about 2.7 hours. So the zero x-intercepts or horizontal intercepts of s of t, the position function, the original function, is t equals about negative 0.274 hours, which is insignificant in my opinion, based on the fact that we are looking at the time interval of 0 hours to 5 hours. Therefore, s of t equal to 0 is insignificant for the time value is negative. So we have the 0 for it, but it's not really important in my opinion. I don't know what we could use it for in this context. The zeros of vt, the zeros of the velocity function, are t equals 4/3 hours, which is about 1.33 hours, and t equals 4 hours. These zeros are significant based on the fact that v of t is equal to the derivative of st. The zeros horizontal intercepts of vt correspond to the slopes or velocities of the traveler and the position function s of t. The zeros of vt, horizontal intercepts of vt, correspond to when the velocity of the traveler is 0 miles per hour on the position function s of t. So if we look back on the parabola, so our zero, well, let's do this. Let's try to do this right. So our 0 for the s of t function is insignificant because it's negative. But our zeros on the parabola, the velocity function, are significant because at this point our velocity is 0, and at this point our velocity is 0. At this point corresponds, let's get the parabola out of here, to the vertex right here at t equals 4/3 hours, where the velocity is 0, the slope is 0, there's a horizontal line, and then at t equals 4 hours, our velocity is once again 0, there's a horizontal line, 0 miles per hour, 0 miles per hour. And that is why these two zeros are significant on the parabola. Now, if we look at the third one, acceleration. Alright, So the zeros of the acceleration function, are they significant? The zero horizontal intercept of the acceleration function at is significant for the acceleration function a of t is equal to the derivative of the velocity function v of t. Therefore, the zero of at corresponds to the slope at the vertex on the graph of vt, which is an acceleration of 0 miles per hour squared. The zero of at is at t equals 16 over 6 hours, which is about 2.67 hours. And the acceleration of the traveler at t equals about 2.67 hours is 0 miles per hour squared. And the velocity of the traveler at t equals 16 over 6 hours is negative 5 1/3 miles per hour. So this 0 point, this is the acceleration function, the linear equation. And the 0 point on this graph corresponds to the slope of the vertex on the velocity function. So at this point, the vertex of the velocity function, the acceleration is 0. And past that point, acceleration begins to speed up. So, since the slope of the acceleration line is positive, I imagine the acceleration excuse me, is always increasing, because that's what it kind of looks like. So, acceleration is constantly increasing. At least past this point, it's increasing in a positive direction, which corresponds to increasing from 0 on the vertex. So no, I guess it would be acceleration is decreasing towards 0. Well, it's increasing towards 0, but it's negative on the linear function. And it's decreasing on the parabola. Acceleration is decreasing towards 0. It arrives at 0, and then it begins to increase on the parabola. So it's alright. So the 0 of at is 16 over 6 hours, which is about 2.67 hours. And that corresponds to where the acceleration is 0 miles per hour squared. I hope I kind of explained this okay. I have a hard time with this part, but yeah. Thanks for watching my video on this project. Yeah, thanks.